In this video, we're going to talk about reference angles and how to find them. So first, let's review the four quadrants in the unit circle. So this is quadrant 1, this is quadrant 2, quadrant 3, and quadrant 4. Quadrant 1 exists between 0 and 90. Quadrant 2 exists between the angles of 90 degrees and 180. And then for 3, it's between 180 and 270, and quadrant 4 is between 270 and 0, which is also 360. Now, let's say if you have an angle in quadrant 1, the reference angle is equal to the angle that's in quadrant 1, which means that the reference angle is always between 0 degrees and 90 degrees. It's an acute angle. Now, let's say if you have an angle that's in quadrant 2, that is between 90 and 180. The reference angle is equal to 180 minus the angle in quadrant 2. Now, for an angle in quadrant 3, the reference angle is going to be the angle in quadrant 3 minus 180. In quadrant 4, the reference angle is 360 minus the angle in quadrant 4. So, let's work on an example. Let's say if we have an angle that's 210 degrees. What is the reference angle of 210? So first, let's plot 210. 210 is in quadrant 3. It's between 180 and 270. So this is 210. The reference angle is the angle formed between the point of interest and the x-axis. So keep in mind, this angle here is 210, and this angle is 180. The difference between 180 and 210 is equal to the reference angle, which is the angle that is formed inside this triangle. Or you can use the equation. For an angle in quadrant 3, the reference angle is going to be the angle in quadrant 3 minus 180. So that is 210 minus 180, which gives you 30 degrees. So this is the reference angle. Let's try some more examples. Now let's say if the angle is 160. What is the reference angle? Now 160 is in quadrant 2. So we'll call this theta 2. So the reference angle is going to be equal to 180 minus the angle in quadrant 2. So that's 180 minus 160, and that's 20 degrees. Now let's show the answer graphically. So 160 is over here. This is an angle measure of 160 degrees. 180 is from here to here. That's half of a circle, so that's 180. The reference angle is the angle inside the triangle, which is the difference between 180 and 160. And so that's 20 degrees. So the reference angle is always the angle between the hypotenuse of the triangle formed and the x-axis. Let's try one more example like this. Try 314. What is the reference angle of 314 degrees? So this is an angle in quadrant 4 because it's between 270 and 360. To find a reference angle, it's going to be 360 minus the angle in quadrant 4. So that's 360 minus 314, which is equal to about 46 if my math is correct. So now let's graph it. So 314, that's about, it's pretty much almost right in the middle. So this is an angle measure of 314 degrees. from here, this is 360 degrees. The reference angle is the angle between the hypotenuse of the triangle formed and the x-axis, and it's the difference between 360 and 314, so it's 46. It's the acute angle formed inside that right triangle. Now, what if you have an angle that is negative? What would you do to find the reference angle? In a situation like this, you want to find a coterminal angle that is between 0 and 360. To find coterminal angles, you can add or subtract 360 to the angle you're given. So we want the angle to be between 0 and 360, so we need to add 360 to it. Negative 170 plus 360 is about 190. If you were to plot negative 170 and 190, they would land in the same position. 190 is in quadrant 3. Negative 170, you have to travel in a clockwise direction. It's also in quadrant 3. They exist at the same point, so they share the same reference angle. Now 190 is in quadrant 3, so let's call it theta 3. So the reference angle is going to be the angle in quadrant 3 minus 180. So that's 190 minus 180, which is 10 degrees. So that's the answer. Now what if you have an angle that's larger than 360? Let's say 500. What is the reference angle for this angle? So first, find a coterminal angle that's between 0 and 360. Since 500 is greater than the range between 0 and 360, we need to subtract by 360. So we get a positive coterminal angle that's 140, which is in quadrant 2. And to find the reference angle of an angle in quadrant 2, it's going to be 180 minus the quadrant 2 angle. So that's 180 minus 140, which is equal to 40 degrees. So this is the reference angle. Now, what if you're given an angle in radians? For example, 5 pi over 3. What is the reference angle of 5 pi over 3? The reference angle of 5 pi over 3 is simply pi over 3. The reference angle of 4 pi over 3 is also pi over 3. And the reference angle of 2 pi over 3 is pi over 3. It simply works out that way. Now the reference angle of 3 pi over 3 is not pi over 3. 3 pi over 3 can be reduced to pi. But typically if they can't be reduced, then that technique is going to work out. 5 pi over 6, 7 pi over 6, and 11 pi over 6. They all share the same reference angle of pi over 6. So these work out for the common values in a unit circle. 3 pi over 4, 5 pi over 4, and 7 pi over 4 share the same reference angle of pi over 4. Now pi over 2 and 3 pi over 2, they don't have a reference angle because they're not in any particular quadrant. They're just on the y-axis. So it won't work for that. Now what about an angle that's not commonly featured in a unit circle? For example, 2 pi over 5. That's not an angle that's to be memorized in a unit circle. So what is the reference angle of that? For the unusual angles in radians, it's best if you convert it to degrees by multiplying it by 180 over pi. So 2 times 180, that's 360, divided by 5. 360 is basically 36 times 10. And 10 is 5 times 2. So we can cancel a 5, and 36 times 2 is 72. So this is 72 degrees. because this angle is in quadrant 1, it's also equal to the reference angle. So therefore, in radians, it's simply 2 pi over 5 is the reference angle because it's between 0 and 90. Let's try another example. What about negative 11 pi divided by 15? Go ahead and find a reference angle. So first, let's convert it to degrees by multiplying it by 180 over pi. So we have negative 11 times 18 times 10 divided by 15. 18 times 10 is 180. And 18 is basically 6 times 3. 10 is 5 times 2. And 15 is basically 5 times 3. So we can cancel a 5, and we can cancel a 3. 11 times 6 is 66. 66 times 2 is 132, but this is negative 132. Now we need to find a positive coterminal angle. So let's add 360 to negative 132. So this is equal to 228 degrees. Now 228 is an angle in quadrant 3. So to find a reference angle, it's going to be the angle in quadrant 3, 228 minus 180, which is 48. So 48 is the reference angle. Now, since we started with an angle in radians, we probably want our final answer to be in radians. So let's convert 48 back into radians. So we have 48 degrees, and let's multiply it by pi divided by 180. So 48 is basically 8 times 6. And 180, we know it's 18 times 10. 18, we can break that into 6 times 3, and 10 is 5 times 2. 8 is 4 times 2, and we can cancel a 2, and we can get rid of a 6. So this is going to be 4 pi divided by 15. So this is the reference angle for the angle negative 11 pi over 15. Try this one. Find a reference angle of 7 pi divided by 10. So let's multiply it by 180 divided by pi. So 180 is 18 times 10, and we can cancel the tens. So then this is just 7 times 18, which is about 126 degrees. So that's the angle in degrees, and that angle is in quadrant 2, which is between 90 and 180. So the reference angle for a quadrant 2 angle, it's 180 minus the angle, or 180 minus 126, which is about 54. Let's make sure my math is correct. So now all we need to do is convert the angle in degrees back into radians. So this is the reference angle. So 54 degrees multiplied by pi divided by 180. 54 is basically 9 times 6. And 180 is 18 times 10. 6 is basically 3 times 2. 18 is 9 times 2. So we can cancel the 9 and the 2. So the final answer for this one is 3 pi divided by 10. That's the reference angle. So what's so important about reference angles? Why do we need to know them? And how can it help us to solve trigonometry problems? Now let's say if you want to find the exact value of sine 150 degrees without using a calculator and without having access to the unit circle, what would you do? What can help us is knowing the special right triangle, the 30, 60, 90 triangle. Across the 30 is 1, across the 60 is root 3, across the 90 is 2. Now for this triangle to benefit us, we need to calculate the reference angle, because notice that 30 and 60 degrees are acute angles. What is the reference angle of 150? 150 is an angle in quadrant 2. So the reference angle is going to be 180 minus the angle in quadrant 2, so it's 30. Sine 150 and sine 30 are equal to each other. Sine is associated with the y value. The y value in quadrant 1 and 2 are both positive. So if we can evaluate sine 30, we could find the value of sine 150. And that's why reference angles are important, because it can help us to evaluate the sine of other functions. So what is sine of 30? Perhaps you heard of SOHCAHTOA. If you focus on the SO part, it means that sine is equal to the opposite side divided by the hypotenuse. So sine 30 is equal to the side that's opposite to 30, which is 1, divided by the adjacent side, or the side that's next to 30, which is root 3. Actually, wait, I take that back. It's not adjacent. That's tangent. It's divided by the hypotenuse. So opposite is 1. The hypotenuse is across the box. That's 2. So sine 30 is 1/2, which means that sine 150 is also 1/2. And that's why reference angles are important. It helps us to evaluate trig functions. Now let's say if we want to evaluate tangent 5 pi over 3. Go ahead and pause the video. Use the 30, 60, 90 triangle to find the answer. Now first, what is the reference angle of 5 pi over 3? The reference angle is simply pi over 3. Now we may need to add a positive or a negative sign, so we'll add that later. Now what is the angle measure of pi over 3 in degrees? So let's multiply by 180 over pi. So the pi's cancel. 18 divided by 3 is 6. So 180 divided by 3 is 60. So pi over 3 is equal to 60 degrees, which means that 5 pi over 3 is 5 times 60, or 300 degrees. Tangent is positive in quadrant 1. But in quadrant 4, tangent is negative. Tangent is basically y over x. The y part of tangent is negative in quadrant 4, but x is positive. So tan 5 pi over 3 is equal to negative tan pi over 3. So make sure you add that sign. So now let's use the 30, 60, 90 triangle to find out what tan pi over 3 is, or tangent of 60 degrees. So across the 30 is 1, across the 60 is root 3, across the 90 is 2. Now we're looking for tangent of 60. And according to SOHCAHTOA, if we focus on the TOA part, tangent is opposite over adjacent. Opposite to 60 is root 3, and adjacent to 60 is 1. So tan 60 is simply root 3. So tan 5 pi over 3 is going to be negative times root 3. So that's the answer, negative root 3. That's tangent 5 pi over 3.